All right, another review. Remember that we can reduce carboxylic acids using lithium aluminum hydride. So if we've got this carboxylic acid, add some lithium aluminum hydride, then add water as a workup step, we end up with the alcohol. Let's take a look at this mechanism because it's a little bit more complex. So lithium aluminum hydride, along with being a good nucleophile, is also still somewhat of a decent base. And so acid-base reactions are always faster than any other type of reaction. So the first thing that's going to happen here is an acid-base reaction. And we'll end up with a carboxylate. The next part of this mechanism is a little bit weird, but not too bad. Basically, what happens here is we have the lone pair of the carbonyl. It can essentially bond to this aluminum, and then we have one of these kind of square, kind of Wittig type reactions. This pi bond goes up and joins the aluminum, and then this ALH bond bonds to the carbon, right? So that hydrogen is now joining that carbon. Right, so now we have that oxygen attached to essentially what's a Lewis acid, and then we have this hydrogen right here, and then we have this negatively charged oxygen, which can kick its lone pair down to form a pi bond, and then now this oxygen is attached to a good leaving group, so it can go ahead and leave. At that point, we're reduced down to an aldehyde. This will continue to go to a carboxylic acid, or my bad, an alcohol, but we already learned this, so I'm not going to go over the mechanism. Review it if you need. As you can see, this is kind of a little bit inconvenient because this lithium aluminum hydride will reduce all kinds of things. And also lithium aluminum hydride is not the safest reagent to work with. So there's actually a much easier way to do this. And so what we can just do to carboxylic acids is just add borane in THF. So BH3 and THF will also reduce it down to an alcohol. And overall, this is a much better reduction. The first thing is it's milder. Don't have to use lithium aluminum hydride, which is very reactive to air. And this is also more selective. It'll only reduce carboxylic acids. It won't reduce ketones and aldehydes. So know this reaction, but we won't go over the mechanism here.